Good morning, everyone. Thanks for having me here on this presentation to talk through on interconnecting intelligence. This is a very difficult subject. Barely see the audience. I really hold on to the remaining audience to what I have. Quickly, Vinay, I've been part of Lightstream and leading the planning and operations team. 25 years ago, I started as a pre-sales engineer designing for the networks. And I had a multinational company as one of my customer. So we upgraded their bandwidth from E1 to DS3. And it's like big thing those days. So my account manager said, OK, let's go and visit the customer. So we went to a customer, and as usual, he showed me the server room and the rack room, and he said, OK, I'm all ready. Your router is here. We are waiting for the link. And he had a big hole in the network room. I asked him, why this big hole? He said, you said there's a bigger pipe coming in. So there was E1 to DS3, thought there's a bigger pipe coming inside the server room and had a big hole ready to get the link in. So technology is sometimes is brutal because it comes with a lot of jargons. And people who know how to surfboard the technology will go through the wave. Other it will definitely wash us out from where we started the jargons, right? So it's almost been 30 years. The network has been evolving, and we are in a great place where another evolution is happening. And this is a privilege to speak about it. I prefer this to be a conversation rather than a presentation. But whatever the best we can get out of today, let's do that. Yeah, this is where I wanted to start the presentation. This is a very courteous words. We start, OK, thank you. We appreciate it kindly. I think this human evolution to the AI evolution, these words should not be required anymore in the AI world. Why is because each of this on the network is going to be a token. And today, AI network is built on the tokens. So the more I use it, you look at the billion scale, I'm going to spend tens and thousands of dollars just because my prompt I'm going to send a thank you to AI, which doesn't really need to be thanked, right? So there are a lot of evolutions happening today in terms of how the prompt engineer is going to change, how we are going to bring the intelligence into it. And if you believe all tokens are generated in the same way or the same intelligent way, I think we'll be wrong very soon. And are we going to build a network which is going to carry these tokens and it will cost us? Is something everybody is trying to answer. And how we are going to do that is a question, and it's a very large question everybody is trying to answer today. And this is a tokenomics. I really wanted to talk about why this is economics of the AI and how the tokens would really cost us in building the network and how we really need to monetize this. So quickly to the arithmetics of it. So all the data is publicly available. So there's nothing that I made up on this, no hallucination to greater extent. AWS has put up this costing on their website. So essentially, they talk about how 8 GPU would cost, and per hour how much they're going to charge. And if you have a 10,000 GPU, it would cost around $39K. And if you really bring down to a second mathematics, basically, it costs around $10.93, basically per hour. So if every 1 second in a minute, if a network goes idle, you lose $10.93. And if I do that for a year, you lost 5 million straight away. And this mathematics is super intangible. You will not be able to find it out because this is being very transparent to you, and you're not really gathering the economics at the token level, and you're really just spending the OpEx, and this is going through. The reason this is very important is everything we are going to build in the network, in the AI, it's all synchronous. The whole traffic pattern is way different how in AI is going to build, how it's going to operate, how everybody is going to monetize, and how it is going to move away from bits, packets, to tokens. And that's where the tokenomics is going to influence the way we are going to build a network, the way we are going to operate the network that is cut for AI workloads. And these are some of the industry-wise figures that has been put. Personally, I believe these are super conservative figures. McKinsey said at a 35% of CAGR, around 93 gigawatt of data center capacity will be just for the AI workloads. And they said that. And we also have figures which is going to say like it is going to increase by 700% on the traffic, and most of the traffic would be AI inference, and 55% of the traffic on the network would be AI-based network, AI-based traffic, and that's going to happen in next to 3 to 5 years. Alphabet had an investor summit 3 days ago, and their tokens were quadrupled. Wherever they were from last 3 months ago, it quadrupled. If Alphabet is going to say that it's going at 400%, you have the worlds of OpenAI or the worlds of Claude, you have the Llama. You can just imagine the scale. The whole AI network is going to explode and accelerate in the AI scale. So we know that there is a log scale, there is an exponential scale. I think the new jargon probably would be AI scale. And the very interesting number in this note is like 26%, which Nokia published in their paper, saying that it's going to be a machine-to-machine traffic that's going to hit. It's very interesting when I saw that number. Basically, a few days ago, my boss asked me for one of the interesting, very important project, send me a daily update, end of the day, what's happening, right, on the project. So all I'm doing is read several emails and make a digestible information to him, and before I go to bed, just send it and go to bed. That's my ritual of the day for last 7 days, basically. But I thought, if I'm really doing nothing but reading emails and digesting and sending it, why cannot my agentic AI can do it? So all I have to do is just create a prompt, it goes and reads a specific folder, reads the latest emails, create a digestible information, and sends it to my boss. And he's a tech-savvy boss. And he has already something prompt sitting there. He says, if this is the email which is coming on with this is the end goal, I want to have it. And I say, get up in the morning, I see there's an email already on it. He's actually like 2.5 hours behind me in the time zone. But I see he's already responded like 4 a.m. or 5 a.m., whatever. So essentially, we just both are proxying each other through our agents. I don't think we need to do that. The agents should start working on their own, and it should really amplify and make us efficient way we want to do it. And these numbers are like staggering. And we are going to come up with this kind of a traffic pattern, and we have the tokenomics, where every GPU idle time is going to cost us millions of dollars. How you are going to build a network would be still a question. We know what is why, but how is something we are still figuring it out to answer it. So just keeping it like jargon-free as much as possible, right? So we have come through like 3 eras of the network. One is where the internet traffic started, like from the days of the modem, which is connecting to 28.8 kilobits per second with all the creak sounds, and you hooked onto it, there's a cache, you're downloading the MP3 songs, you're looking at the JPEGs, and then you look up a PDF file. So it was all about caching. It was just like best effort basis. An IP engineer probably in 2005, if he knew the MPLS protocol and a BGP protocol is set, I think he would have told himself, I'm set for next 20 years of my life because the internet is just going the way it is going. But I think came 2008, 2007, the cloud started exploding. The cloud was not just about moving the data. The cloud was moving the applications. The traffic moved from north-south to the east-west. And it changed the whole pattern of how the network should behave and network should operate. And that's one reason why the hyperscalers came into the existence, because the telcos of that world were not ready to meet the hyperscale level of the traffic to manage, and to manage that they were not ready to build For them to build, they're still stuck behind the jargons that, okay, whatever I have today is going to work. Now comes the AI era. So this is totally different from what cloud and hyperscalers have built a network, and they are evolving as well. It's a matter of time that they evolve their own architecture and they're deploying it, and they're actually doing it as we speak about it. AI is about like a lossless, deterministic, prescriptive network. And what matters is not the throughput. What matters is not just the availability. What does not matter is also just the latency. It's also some of the patterns like jitter. When is my last packet or the token is coming and hitting my GPU? If it is not coming, I have to restart all of my workflow again, and I lost so much amount of time in synchronizing those workloads, and there's an idle time. That idle time actually translated into the tokenomics again, and I lost so many dollars into that. That's measurable. So AI is going to change how the network is going to evolve and how it is going to manage the traffic patterns. So we talked about two types of the traffic. Why we talk about AI training and we talk about AI inference. And there's a little shift in how each of these traffic patterns happens. AI training is more like a burstable traffic. It just comes in like a spurious way and hits at like 800 gig or 400 gig at speed, and all it cares is like jitter, but it is okay for it to go all the way from Mumbai towards Singapore. It doesn't matter. But am I available all the time? Is it in a deterministic network? And is it my jitter is always going to stay constant? So essentially, jitter should be a 0 in an ideal world. But imagine today's network. Most of the network is built on like 1 + 1 path or 2 + 1 path. And if my network is AI training is running on that n + 1 path, and a primary path goes down, and there is a switching time of 50 milliseconds, your jitter is 50 milliseconds. And it has to restart the load just because it switched to a secondary path or restoration path. So how am I going to give in a high availability network, but I don't want to over-engineer the network, but I want to keep the jitters 0 and still run the AI training is the puzzle everybody is looking to solve. And there is not going to be like one solution to it. There is a technology advancement is happening. There is an evolution and the automation is happening, and how the hardware are going to respond, whether at optical layer or it's going to respond at IP layer, or the whole stack level is going to define. So AI training is like a distributed computer. So all those data center buildings in different geographies are just getting assembled, and it makes one big motherboard, and we are running the training on it. That's because we have a lot of scarcity of the GPUs, scarcity of the power. We cannot have all of those trainings running in the same centralized place. So that's the behavior of AI training. But AI inference is the one which is also exploding equally. I think probably next 3 years it's going to dominate the traffic. And it resides where the user is sitting in. It needs to be at the edge. For it, all it matters is latency and a continuous conversation and a streaming that's going to happen. And there's not going to be any cache in it. We used to have the CDN concept when we really built the internet. You can store a Netflix content there, and you can press it and just keep downloading it because there's a cache. I know what is coming. But I cannot do a cache, which is like a KV cache in AI, because I do not know what prompt you are going to generate. I do not know, like, if this is the prompt it's coming, this is already in a data, this is what I'm going to serve for you. So the edge compute is going to change the way it is going to manage the traffic and handle the traffic. And here where the latency comes into the picture. And again, it's still in a deterministic network. So if you just take a simple example, you have a customer, let's say he's a neoscaler or a hyperscaler, and he's building a network to you, say, hey, I want a bandwidth from Mumbai to Singapore, 800 gig on a week 1. And then when I finish my training, I want to come back to Mumbai to Chennai or Mumbai to Delhi for inference, 800 gig. Are you going to build 2 800 gig pipes to him? Or are you going to build 1 800 gig pipe to him? How much we are going to over-engineer him? Where is the cost of building the network would come in? Let's say I build both the networks. How I'm going to monetize that network I built it? Is customers ready to pay for the idle network? So those are the questions eventually the industry would start answering it. And if we in this room, we are not going to answer that, I think there will be a next generation of the people coming and building this. We had hyperscalers coming in. And neuroscalers are something like, they are not telco, they are not hyperscalers, they're not really like a dedicated neutral pipe coming to the customers. They are going to build a network which is going to be intelligent, which is going to be monetized, but it still gives you all the parameters and the attributes the AI workloads needs to manage it. And this is essentially a different category of the set of people who are going to do it. They need to find out how to solve the problem of switching, how to solve the problem of availability, how to solve the problem of jitter, how to solve the problem of latency, and still run the network at the cost I can run it and still make the money from the business. And this is the only how part I have it. Just not going too deep into it, how we want to do it. So in bottom line, AI traffic is nothing but a traffic that comes with an intent and need to move that information with an intent. That's the bottom line. So for example, these are the 5 parameters I have put actually. I think the security should have been top of that after Mythos really came up and said that Glasswing is going to shake the whole of the security world. I think security in the AI will be the top thing to do today. So it depends on the customers. When a really customer looks at your BFSI customer and a healthcare customer looks into it, where is my GPUs available for doing a compute, or I'm doing an inference? Can I go to that place dynamically, right? And to go to that path, what is my real-time latency and jitter? I need to see this. This is like you pick up your Google map and you say, I need to go to airport. Okay, now if I go, it takes 1 hour. If I go some other time, it takes 30 minutes. That's my traffic pattern. So how, as a network builder or network creator, I'm going to provide that information to my customer on a real-time basis? He chooses to go to that path, he chooses to select that path and run through his network on it. So these are some of the things, and sovereignty is going to be a very key thing. That's basically a data resident that's going to tell you how you need to position your data, where it needs to position data, and what needs to go run on a compute, what needs to run on an inference. And that all of this is in a dynamic allocation of the bandwidth. And all of us are trying to find out how we are going to build this network, which is basically in a bandwidth that moves with an intent. How I manage the customer without over-engineering, without building the infrastructure on an overscale, how I'm going to do that is something we're really looking to answer. And we are also looking to partner with various industry leaders. And I was in demo with Nokia team yesterday. It's fantastic. I've been speaking to Nokia from last 6 months, and this month when you looked at the demo, they moved it on a leap scale, basically. And if you see the demo, there are like 12 demos, there are like 6 to 8 of them are on automation, how AI agentic is going to change to them. So the industry is evolving towards it, and we are trying to build a network, which is mostly for us is a scale across network. It has to be an intelligent network. And it also respects the sovereignty on how we are going to build it. And this would be a purpose-built digital infrastructure, right? This cannot be an existing telco network that we built for 90s. It definitely cannot be a hyperscaler network we built like just 10 years ago. This would be a network that we are going to build for the next 5 to 10 years on this. So This is a great opportunity for giving me a talk through this. I know this is like an endless topic. By the time I finish this session, there will be something would have changed in the technology space, and I just have to refresh with the new content and come back on it. So thanks for having me here. It's a privilege to be here on the stage. Thank you very much.